Hello, my lovely mathletes. Welcome to a little bit of homework help in Unit 4, Lesson 10. Question 1 has two parts. Please remember to scroll down. For the first question, it says match the lines M and N to the statements they represent. So as we look through these ones, we have just a couple of statements. A set of points where the coordinates of each point have a sum of 2. What we're talking about here is we want to make sure that the sum of the coordinates, when we're talking about that, is where we get x plus y is equal to 2. So the other one, it says a set of points where the y coordinate of each point is 10 less than its x coordinate. So the other one that we're looking at is a y coordinate that is 10 less than the x coordinate. So hopefully that gives you a little help to look at this piece that we can recognize. I suppose we don't really need the parentheses, but what we do is we're recognizing how these different pieces are working together. So which line would go where? We want to go ahead and look at those pieces that come down here, line M or line N. And when we look at line M, I lost those. Line M is the one with the positive slope, starting here at a minus 10. So that one would have to be line M that comes right here. And line N would have to be the other one. Perfect. The second part of this, match the labeled points on the graph to statements about their coordinates. So this is like what we saw in the lesson where we're talking about what is true for one or true for both or true for neither. So two numbers where the x coordinate is 10 less than the x coordinate, two numbers with the sum of 2, and where the x coordinate is 10 less than the other numbers, and two numbers with the sum of 2. So as we look back at these, we're looking at these points A, B, and C, D, and E. And what we're looking at is we want to match those up with these spots right up in here. So points A, B, and C, let's look at what they all have in common. A, B, and C are all on line N. So pay attention with that they're all on line N. Which of these describes only line N? As we looked at line N, we saw that line N has a sum of where the points are always 2. When we add them together, one of those places what we can look at is right here with letter C. We see this is 12 and negative 10. And when I take 12 plus negative 10, it equals 2. So it satisfies the equation. This would be a solution. I could say the same thing right here. 6 plus negative 4 is positive 2, and negative 2 plus 4 is also positive 2. And so we see that those ones all fit there. So what we want to do with this one is we want to select and say the two numbers with the sum of 2 is points A, B, and C. Point B is very unique because point B talks directly about both lines. So we have to figure out where are both lines going to be true. Well, the two numbers with the sum of 2 and where the y coordinate is 10 less. And I think you can figure out the last one. Question number 2. This is just one question. Here's an equation. 4 times x minus 4 is equal to 4 times x plus what? Select what you could have in the blank so the equation would be true for no values of x. So we want this to be absolutely false. So what number can I substitute there to make this completely false? Remember that we have a 4 times x and a 4 times x, which means that if I eliminate those, I'm just left with my constant values. And so when I'm left with just my constant values, to be no values of x means no solution. My constants cannot be equal. So in there, where would I put one in that is not equal? When I look at the first one in here in the box, I see a minus 4 right there. So I cannot choose minus 4. I would have to choose 19. All values of x, I want to make sure that these are exactly the same expression. So we want to pick the one that makes the exact same expression. And then right here, which one makes the coefficients of x different? So hopefully you've eliminated a couple of pieces from that one. Go give it a roll. Question 3 is 2 parts. Please remember to do both. May earns $7 per hour mowing her neighbor's lawns. She also earns $14 for hauling away bags of recyclables for some neighbors. Priya babysits her neighbor's children. The table shows the amount of money she earns, or the amount of money M she earns in each hour. Priya and May have agreed to go to the movies the weekend after they've earned the same amount of money for the same number of hours worked. So how many hours do they each have to work before they get to go to the movies? when we look at these pieces, we have to look at the two of them, what we're given. And what we see right here is this table is Priya's table. And we have to recognize, what does that mean? Priya, what we look at, it shows that the amount of money M she earns in hours, and all we know is that she's babysitting those children. What I see right here is that after 1 hour, she's made $8.40, and after 2 hours, that value has doubled. And after 4 hours, doubling the 2 hours, that's doubled again. So I can conclude that Priya is making $8.40 every single hour, so that her total amount of money earned is here. Now, actually, I do need the M, but I don't need the M. So we're going to look at this. When we talk about using M with May, we need to use the same variables. So the amount of money that May earns is equal to $7 per hour plus the $14 that she made for hauling things away. So how many hours do they have to work to be able to go to the movies when they have the exact same amount of money, and how much money would they have? So what we want to do is we want to solve for H. Since this is how many hours, we want to solve for H. But the cool thing is we know that when the money is equal, that these two expressions should be equal. So we should say that 7 times H plus 14 is the exact same thing. I'm going to do something kind of weird here, so follow through with me, is equal to the money. This is for May. But then when we see Priya, her money is earned by $8.40 per hour. Now, recognizing that both of these expressions equal to M, what we can do with this is say that both of these expressions, since they equal the same variable, could also be equal to each other. And by being equal to each other, we have the opportunity to go ahead and solve for H by using the subtraction property of equality to get rid of that $7 per hour, which leaves us with $14 of difference over $1.40 per hour difference. We'll divide that by $1.40. And then we're going to use our calculator that's embedded here. Bear with me that it's through a lot of stuff. I should place that better. But 14 divided by 1 4/10 should equal to 10. And it does equal to 10. And so what that means is that the number of hours is equal to 10 hours. And after 10 hours, when they have the exact same amount of time together, here's our next step. Our most important step is to go ahead and plug that 10 back in to our expressions right up here and right here. And when we find that, we're going to know how much money they had. So after 10 hours with May, that one's pretty simple to me because I know $8.40 for 10 hours gives her $84. I want to make sure that this is Priya, make sure that May has the same amount. So 70 times 10 plus $14 that she earned makes that 70 plus 14, which is also 84. So I know that they've earned $84 together. They've worked for 10 hours. They have $84. Now they have the same amount. Now they can go to the movies. Whew, take a deep breath. Let's go down to the second part of the problem. Complete the statement about where the solution can be seen in the graph that represents Priya and May's hourly earnings. In the graph, obviously there's not a graph here, so if we saw a graph, the solution is found in the coordinates of the points HM, 0M, or H0. Meaning, is it on this one right here, the 0M would be our y-intercept, H0 would be our x-intercept, or is there a place where their two lines would intersect differently, where the graphs of the two relationships intersect? This would be the thing that we're after with that piece on part B and what that question is after. Question 4. Multiple parts to this one. We just need to match them up. This is a review from lesson 4.6. Always check to see if we can scroll down. And what we're doing is match each equation with what you could do first to each side of the equation so there would be no fractions. So our whole goal is to eliminate fractions. In this case, the first one right here, I see an 8 and I see a 3. I know that 8 and 3 3 does not go into 8, so 8 is not a common factor or a least common denominator for these. One of the strategies that we can do with this is a question that's been asked of me recently is when I'm finding common denominators, could I just multiply these two denominators together? And that answer is absolutely yes. So the question that comes down to is when do I do that? And the only time that I do that is when I want the least common denominator to be the least common multiple. And the reason I bring that up as being so important is because you look at the second one here, 4 times 6 is also 24. But the difference between the two, when you look at 8 and 3, that least common multiple is 24. We know that 4 and 6 are both factors of 12, which is a smaller number. And so we can differentiate it by the two based on what we know about those numbers as factors. So when we put these in here, we're going to know that this one will be the 24, and then this one will be the 12. And then we can compare the other ones about 30 and 8. So pay attention to these other pieces. Looking right here at option number 3, or this third equation, 4p plus 3 divided by 8 is equal to p plus 2 divided by 4. 8 and 4 are not factors of 30, so that one can't work, but they are factors of 8. And then 15 and 6 are factors of 30. So hopefully that's enough information for you to finish that one out. Last question has a lot of parts to it, so please follow along with it. The owner of a new restaurant is ordering tables and chairs. He wants to have only tables for 2 and tables for 4. So that means that's the maximum that he has going on. The total number of people that can be seated in the restaurant is 120. Now, the cool thing that we're after with this, or what we're doing, is we're actually setting ourselves up to write 2 different equations to find out how many of these will fit. So we're going to ease into this by giving you some information, and then we are going to, in time, have to find out our own information. So let's look at what's set up. It says complete the possible combinations of 2-seat tables and 4-seat tables that will seat 120 customers. I'm kind of impatient, and I would just like to start you off with this, with the 2 equations we can get. When we look at this, he wants to have only tables for 2 and tables for 4. So the question is, how many tables for 2 and how many tables for 4 would it take to accommodate 120 people? The piece of information that we're missing right here is how many tables there are. So we're not quite there to be able to write the other equation just yet. We want to complete the possible combinations of 2-seat tables and 4-seat tables to seat 120 customers. So if we had 10 2-seat tables, that would make for 20 customers. So how many 4-seat tables do we need? Well, then we just solve for y. Subtract 20 from 120, which gives us 100, and then divide by 4. So we would need 25 4-seat tables. So now let's flip that around and change just a couple of things. We want to come back here. Let's fix this back up. And notice what we actually have to change. At this point now what we're doing is we're finding x for our situation. And what you'll notice is there's not a lot that I have to change here. Just a few little things. So in this case, I have 10 seats, which makes that 40. So I'm going to subtract 40, which leaves me with 2 times x is equal to 80. And as I divide by 2, I find out x has to be 40. These are just 2 solutions for this that could be possible combinations. So complete the equation to represent the situation. Let x represent the 2-seat tables and y represent the number of 4-seat tables. I jumped to this one early because I wanted you to recognize that the equation tends to be the most efficient way to do this. And in my experience, this is what I've seen most students jump to first, is they either jump to a table or they jump to an equation. And so in this case, that equation, it's 2 people for the 2-seat tables. So when we have those number of tables, I don't know how many tables there are, but I know that 2 people can sit there. And I know 4 people can sit at any number of these tables. And so I come up with this equation, 2 times x plus 4 times x is 120. Now our job is to look at our graph down below and figure out which of these graphs are going to be accurate, graph A or graph B. Now let's think about that. We have 120 seats available. So of those 120 seats, let's say we just divided that by 2. And what we recognize with this is that it's 120 seats divided by 2 would mean that if we only took 2-seat tables, we would have 60 total tables and no 4-seat tables. The flip side of that is we have 120 divided by 4, which equals 30 tables. Now, what you'll notice on each of these graphs is you have one where you have 30 there and 60 here and 60 here and 30 there. So they've switched these around for the 2-seat tables or the 4-seat tables being the independent variable. And the common thing that we do in math is when we talk about these tables, the number of tables, what we talk about and when we decide which one is X and which one is Y is we come back to this situation that came up here where how did this one become X? Why did we put 2 times X here and 4 times Y here? And the whole reason for that is because of the way that it was introduced in the problem. We have tables for 2 that was listed first, and in the ordered pairs, X comes first in the ordered pair, followed by Y. So that means that 2-seat tables are the X-axis. They are the independent value. And 4-seat tables are the dependent value. And so with that information, hopefully what we can recognize and what we can see with this is that if we have 60 tables, that would represent 2-seat tables. And then this one would represent 4-seat tables. So we would have to look at this piece and see what the other graph looks like. And it doesn't match up the same. Okay, it would flip them around the other way. So in this case, we actually want graph A to be the correct graph here. So now complete the statement about what the slope tells you about the situation. The slope tells you that for every 1 fewer 4-seat tables, we can use blank 2-seat tables. Go back to our equation, 2 times X plus 4 times Y is equal to 120. Our goal is to get Y by itself. But for your little bonus to being able to sit here, I want to give you a shortcut for finding the slope when we're in this kind of form. When we're in this kind of form, what we can do with this is we can actually take, this is what we call standard form. A times X plus B times Y equals C. And I mean, this isn't exact standard form. It'd have to be simplified down a little bit, but we're going to see how this works. To find the slope, what we do is we take, when it's in this form, M is equal to the opposite value of A divided by B. What that means is that if I take this term right here, A, the coefficient of X, and divide it by B, I get 2/4, but then I have to take the opposite, which is a -1/2. This would be my slope. The other option that you could do with this, if this makes sense to you, grab onto it, put it into your notes, use that. If it does not make sense to you, then what we need to do is we need to solve our equation to slope-intercept form so we can see the slope, or there's a lot of ways to find this, or we just simply solve this for Y by subtracting 2X from both sides. And we get 4 times Y is equal to -2X plus 120. Divide everything by 4. And Y equals -1/2 of X plus 30. We see what our values are. We see where the situations are. The slope tell you for every 1 fewer seats of a table, we can use 2-seat tables. We can add in 2 more of those. Complete the statement about 0-30. We're after with this one is talking about the y-intercept. So our y-intercept is 30, How many tables would there be for only 2C tables? How many tables would there be for only 4C tables, talking about the X and Y intercepts? And that's your homework. Take a deep breath, do a great job on it. Let me know when you have questions. Make sure to have a great day.